Welcome back, guys. So in this unit, we're going to talk about different probability density curves. We're going to cover a few of them, but they all follow the same rules and the same patterns. So before we dive into it, we're going to look at some probability rules that apply to all of those probability curves. So first definition, we say that a continuous random variable x has a given probability density curve f of x right here if the probability that x is between a and b, written this way, p followed by x is less or equal to a, greater or equal to a and less or equal to b in parentheses, is equal to the area under the curve between a and b for any values a and b. So in other words, there is a connection between the area under the curve and the probability. They're basically the same thing. So if we know the area under the curve between a and b, we know the probability of x between a and b. This is the notation that we're going to use. This is the distribution of x, variable x follows a certain distribution represented by a curve. And as I mentioned a minute earlier, we're going to look at different such distributions. We're going to look at the uniform distribution, normal distribution, chi-square distribution, t-distribution. All right, so stay tuned for that. Now let's talk about probability rules that all probability density curves follow, no matter what their shape. First of all, the total area under the curve is 1, as we mentioned before. Then for the probability of x equals some value c does not matter because that probability equals to 0. With that in mind, probability of x is less or equal to c is going to be the same as the probability of x strictly less than c, not including the equal, because equal is equal to 0. If x equals to c, that probability equals 0. So it doesn't matter whether we include the endpoint or don't include endpoint, the probability is still going to be the same. Same for probability that x is greater or equal to c is going to be the same as the probability of x is greater to c. Okay, and finally, the complementary rule. If we're looking for the probability that x is less than c, in other words, the area to the left of c, we can find it by subtracting probability that x is greater than c from 1. So complementary rule. And one more. A rule is a probability rule, or this probability rule as a subdivision rule. So basically, it says that the probability of x from between 0 and b, so basically this red area highlighted in red, is equal to the probability of x being between 0 and a, basically 0 and a, that's the blue area, plus the green area, which represents the probability that x is between a and b. So basically this piece highlighted in red consists of two pieces, the blue one and the green one. And in order to get this whole area, we have to add these two pieces together if we know what they are. Now, probability that x is between a and b is basically if we know the area of the red, the highlighted in red, and we know the area in blue, then we can take this piece and subtract the area in blue, and that will give us the area in green. Basically, that's what the second line is saying. So basically, altogether, we have three pieces, right? Piece one, piece two. If we put them together, we get this third piece, right? So we can, if we know two of those, we can always find the third one using simple algebra. So let's take a look at some examples. So here we have a probability density curve of the variable x that follows is described by this equation 1/8 x. So here it is, and on the domain between 0 and 4. We already checked before that this is a probability density curve since it's above the x-axis, and the total area under the curve is 1. Okay, so let's use this curve to figure out the probability that x equals 2. Well, as we mentioned before, the probability that x equals a certain number is always going to be equal to 0. What about the probability that x is less than 2? Well, less than 2, that's the area to the left of 2. And here we have a triangle with base 2 and height of 1/4. Okay, so remember the formula for the area of a triangle is 1/2 base times height. So this area is 1/2 times 2 times what's the function value at this point? How high is this point? Well, if we plug in the x, the 2 in the formula, we're going to get 2/4. And that will give us, well, this is 1 times 2/4, that's 1/2. So that probability is 1/2. Okay, what about the probability that x is less than 3? Well, that's the area to the left of 3, this whole piece. So again, following the formula, we have 1/2 times 3, and plugging 3 into x, we're going to have 3/8, and that's going to give us 9/16. So that's the probability. I found a mistake here, I think, because when we plug in 2, we're gonna this is going to be 2/8, not 2/4. So what do we have? We have 4/16. So that's going to give us 1/4. 1/4. Okay, so let's continue. What is the area that x is greater than 3? So that would be the area to the right of 3. However, so we could actually use the trapezoid area rule if we wanted to, but we could also use the complementary rule. So the total area is 1. This piece is 9/16. So the area on the right is going to be 1 minus 9/16. So 16 out of 16 minus 9/16, that will give us 7/16. Okay, so now what is the area? I mean, the probability that x between 2 and 3. So that would be this area right here. So we do know the entire piece from 0 to 3. right? And we also know this piece from 0 to 2. So we are going to take the bigger area and subtract a smaller piece from it in order to get the piece in pink. So that's going to be the probability that x is less than 3. That's 9 over 16. And we're going to subtract the probability of x is less than 2. So that's going to be 1/4 or 4 over 16. So the result is a 5 over 16. And finally, what's the probability that x is greater than 5? Well, 5 is not included in the domain, so the probability of that is 0. Doesn't, yeah, that probability is 0. And what's the probability that x is less than -2? Well, again, this is not in the domain, so that's going to be 0 as well. So in general, knowing those probability rules that we just discussed and knowing basically the shape or the equation of the line that describes the probability density curve, we can figure out different probabilities. And in future videos in this unit, we're going to look at different shapes, different distributions, and how to find those basic areas. That's going to be our goal.